Advanced Math Lesson 89, the ellipse, round 2. So, quick recap of ellipse. We should know the standard form of the equation of ellipse, which is x squared over a squared plus y squared over b squared equals 1. Typically, you'd put the major axis first. That's the way that I was taught, was, whichever the major axis is, that's what goes first. Some people will only do it in x and then y. I guess that's probably personal preference, but I like to stick with putting the major axis first. So if x was the major axis, like right here where it is, it'd be x first. In this one, we see that y is the major axis. All they do here is they switch the letters a and b for major and minor axis. I would go ahead and I'd put y squared over a squared plus x squared over b squared. Mostly the reason for that is not confusing the values of a and b. And now, the question is, why in the world would those values matter? And we're going to learn about it today because of these two things right here called focal points, or foci. And that's what I've got drawn here. I've got drawn an ellipse of the equation, and yes, this is an ellipse. It's not Baymax, like some of you may like to think. It does kind of look like Baymax, but that's not what we're talking about. Nobody say that. This is an ellipse of the equation. Let's see here. X squared over, what in the world is 6 squared? 36, thank you. My brain's working a little bit slower. Y squared, I feel like I say that more and more as these videos go on. Maybe it's just the math is getting harder. My brain's not slower. Maybe the math just deserves that much time to think. Anyways, x squared over 36 plus y squared over 25. Oh, I did it wrong. That's 4. I counted 5 spaces, 4 spaces. Y squared over 16 equals 1. Okay, so we've got a minor axis of 8, a major axis of 12, and then we have right here these two focal points, or foci. We have focus 1, focus 2, or f sub 1, f sub 2. Now the important thing about a and b here is the value a will always be along the major axis, which is why I always try to lead with the major axis. A always comes first. It just makes sense. It's logical to me. That's my reasoning behind it. So let's say that this line right here, this red line, this is value A, right? And then this green line, this is going to be value B, all right? And then that's where we get the equation B squared and then A squared, because 6 squared gives you 36, 4 squared gives you 16, right? So those are our A's and our B's. Now, the important thing to note here is with these two focal points, something cool happens, is you can create two right triangles with side B, okay? Hold on, this is gonna get really good, right? So this from here to here is also side B, right? So we have side B. So now what we have is we have two right triangles with side B. The length of side B is known. It is 4. Now, the reason why this matters is because this length that I drew here, both of these hypotenuses, we'll call them H1 and H2, right? So H sub 1, H sub 2, hypotenuse 1, hypotenuse 2. If you add them together, H sub 1 plus H sub 2 is going to equal 2 times A. Right? Or what it actually means is they're going to equal the length of the major axis. So what we can actually say here is that hypotenuse 1 plus hypotenuse 2 is going to equal 12. Now, the interesting thing is both of these triangles are congruent because the focal points are at equal distance away from the center. The focal points are used in the locus definition of drawing the ellipse. And that's where we get these lengths of H1 and H2. Hopefully I'll mention that in the class, in class when we do this. Actually, I probably will. I love talking about locus definitions. Reference that locus definition of an ellipse. If not, you can Google it or check it out in your textbook. I think your textbook does a pretty decent job of explaining the locus definition, so I'm not going to do that here. Anyways, so these two hypotenuses are also on congruent triangles. So this distance from origin to F1 and to F2 is going to be the same. These angles are both going to be right angles, and the angles that are formed here are also going to be similar. So we've got from angle, side, angle, 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 side. We've got a couple of different proofs that will show that these two triangles are congruent. So since we know these two triangles are congruent and they're right triangles, if I can figure out the hypotenuse of one, then I know the hypotenuse of the other is equal. So we can just stop calling these H1 and H2. We can just start calling them hypotenuse, and then we can say that 2 times the hypotenuse is equal to 12. Now, the question is, how do I figure out what the hypotenuse is? Let's, why didn't I grab an eraser? Okay, so let's clear up some space here on my whiteboard, and let's use our knowledge of this triangle. And the goal here is we want to figure out what the distance is, or the goal here is to figure out the coordinates of the focal points, or if we have the coordinates of the focal points, we can figure out the lengths of another axis. So in this case, what we have here is we have the equation, and we're looking for the coordinates of these focal points. I'm not sure what they are, but I can figure them out using this knowledge. So, if the, I erased the part that I needed, right? So if 2 times these congruent hypotenuse is equal to 12, or is equal to 2a, right? If 2 times hypotenuse is equal to 2a, and then a is equal to a length of 6, 1, 2, 3, 4, 5, 6, then the value of one of those hypotenuses is only 6. So, if in this right triangle I know that this length is 6, I know that this length is 6, can I figure out the base length using, and then I also know that the height, or the b value, is 4, right? I can then figure out the other leg. So all I have to do is use Pythagorean theorem. 6 squared, which is 36, is going to equal 4 squared, which is 16, plus b squared. From here I just have to solve. I'm going to get 20 is equal to b squared, or that b is equal to the square root of 20, or 2 root 5, as we more commonly know it, 2 root 5. So now I know the distance from origin to the focal point is 2 root 5, which means these coordinates, the way I'm going to do this, is focal point 1 is equal to negative 2 root 5, the x value, comma 0. Focal point 2 is equal to positive 2 root 5, comma 0. Right? Or the faster way is you could say the foci are located at plus or minus 2 root 5, comma 0. And there we go, I've got my focal points. Last thing we got to talk about with the ellipse is using this brand new knowledge of how we can use right triangles to figure out pieces of the ellipse. Is what if they give us the focal points, what if they give us the coordinates of 2 of the axes, but then they don't give us the coordinates of another axis. So let's start with a brand new ellipse, a brand new problem. So let's say I'll use the example 89.2. So let's say they tell me that an ellipse has vertices. So the vertices are at 0, comma plus or minus 6. And the foci, one other thing I forgot to mention is that the foci will always be along the major axis. Always, always, always. I should have mentioned that when I was talking about the location of A and B. That's another reason why they matter, because the focal points will always be alongside A. They will never be on side B, and they will always be on the major axis. And then the foci are located at 0, comma plus or minus 5. Okay. I drew in the way of my thing. I should have put this farther in the corner. Here. I'm just going to put V for vertices. They're at 0, plus or minus 6. And then the foci are at 0, plus or minus 5. All right, so let's go ahead and graph this. Vertices 1, 2, 3, 4, 5, 6. There's one vertice, 1, 2, 3, 4, 5, 6. It's the other vertice. Okay, and then the foci are going to be plus or minus 5. I'll go ahead and draw those in black. There's positive 5, there's negative 5. So I've got my focal points, got my vertices. Now I have to figure out the, I need to figure out the equation of the ellipse. So I'm unsure what the minor axis is going to be. All I know is this. These points are unknown. So I'm going to go ahead and sketch, and the drawing is, I believe the drawing is optional. Let me see here. Oh, nope, drawing's not optional. They tell you to graph the ellipse. So this is just a sketch of the ellipse. This is not the actual graph. It can become the actual graph if I label these 2 points. But for right now, what I'm going to do is I'm going to construct that right triangle between the foci and the minor axis of B. All right, so the minor axis is the unknown right now. I do know the length of the major axis, and I know the location of the focal points. So what that gives me, if I know the location of the focal points, I know the distance of the origin to the focus. So this red line is going to be 5, obviously. The hypotenuse is going to be the major axis divided by 2, so 6. So the hypotenuse is 6. Now all I have to do is find this B side of the triangle, and then I know the x value or the location of my other vertices, which will help me find the equation of the ellipse. So I just do good old Pythagorean theorem again. 6 squared is 36. That's going to equal 5 squared, or 25, plus b squared, which means that b is going to equal 11, or sorry, b squared is going to equal 11, or b is going to equal 11. So that tells me that this point right here is 0 comma square root of 11, and then this point is 0 comma negative, oh whoops, I did that backwards. Sorry, I did y and then x. This is root 11 comma 0. This is negative root 11 comma 0. Okay, so now that I know these 2 points, this graph is now accurate. Okay, and then I should probably also label this as 0 comma 6, and then there's 0 comma negative 6, 0 comma 6. Now this graph is accurate. This counts as my sketch, and all I have to do is figure out the equation, which is super duper easy. I just take the major axis of y. I'm going to put y squared over 6 squared, which is 36. I'm going to add it to x squared over square root of 11 squared, which is just 11, and that equals 1. Got my equation, got my sketch, everything's good to go. That's it for this lesson. If you guys have any questions, let me know on Moodle, and I will see you in class.